This video is to go over the time value of money, more specifically the compound interest formula. So let's see what we have so far. Our formula is as follows. A equals P parenthesis 1 plus R over N to the NT. What is P? Is indeed our principal or the present value. A stands for amount or future value. R is our annual rate, always in decimal. Please remember that. T is time in years, and N is the number of compounding periods in 1 year. What does it mean? Of course, N represents how many times we're going to apply the interest rate based on the compounding periods. For example, if we compound the money annually, N will be equals to 1, semi-annually, N equals 2, quarterly, N equals 4, monthly, N equals 12, weekly, N equals 52, daily, N equals 365 days. So let's go ahead and do one example, actually 2 examples. Let me share the following. So this is what we have. Our first example is, let's suppose that we have $2,000 invested in an account that pays 7% compounded quarterly. Find the amount in the account after 3.5 years. This is what we call a compounding problem. Since we have the money, we have today's money, we invest $2,000 today. And then we are going to, at 7% interest rate, and we're going to apply that interest rate 4 times a year, per year, because it's compounded quarterly. We need to know how much money we will have after 3.5 years. So P, our present value, will be $2,000. Our N, quarterly, N equals 4, 7% in decimal, 0.07. And then, of course, 3.5 years, 3.5 years. The second problem that we're going to look at is as follows. We're going to, a couple is investing $7,000 at 3.4% compounded quarterly once again. And we need to know the balance of the accounts after 5.5 years. In other words, after 5.5 years, 0.034 interest rate. So let's see what we have. First example, we go ahead and just plug in the numbers. 7% compounded quarterly 4 times a year. The seed money, the initial value, the deposit, initial deposit is $2,000. And once again, N equals 4, and we are going to over 3.5 years, 3.5 years. Okay, so we just simply plug it in the calculator. Let's see what we have. Okay. This way, hopefully this will work. So we have our, this will be the second example. Since I already typed it in, let's go ahead over it. $7,000, 1 plus 3.25%, 0.034, compounded quarterly. So we divide by 4, and then raised to, notice the parenthesis 4, which is N, times 5.5 years. In fact, this will be this problem here on the red, on the green one that we have. 7,000 initial value, 3.4%, 0.034, compounded quarterly, N equals 4, and then after 5.5 years. Now, the first example is as follows. Let me type it in. That will be 2,000 parentheses, 1 plus 0.07 divided by 4, then raised to, we can type here, I mean, parentheses 4 times 3.5, but we just simply know that 4 times 3.5 is 14. Just go ahead and plug in 14, and the answer will be 2983.83. The first example, the second example is 8434.72. So there we go. So we have the respective answers here. I encourage you to try a couple of additional examples. Let me share the following with you. Let's make it bigger. Just going to going to pause here for a second. Yeah, for examples. And the little boxes in blue, those are the answers that I got. Okay, so of course, at this point, I don't have to wait. You can pause the video, work them out at your own pace, and then you may continue playing the video. Sometimes we are interested in finding how much money I need to deposit today in order to achieve certain goal. And that's what we call the discount problem. These are the two options, namely we have present value. If I deposit some money today, I need to know how much money I will have in the future. That's a compounding example. Those are the first examples we did. And sometimes, of course, we want this amount to achieve certain, buy a house, buy a car, down payment for a house, etc. So we need to know how much money I need to save today in order to get this goal in the future. So that will be a discount problem. So let's go ahead and look at a couple of those examples, namely knowing the goal, knowing the objective A, how much money I need to deposit today. Okay, so let me share the screen once again with the Word document. So these are good examples. Okay, so these are 6 examples. So let's go ahead and work maybe 8 and 10 monthly. No, we'll try 9 and 10. Let's try the following. I selected the wrong problems. Let's go ahead and share the document once again. I pointed out the wrong one. So these are typical examples of looking for present value, knowing the future value. So let's work, for example, the number 17 to get $1,500 after 2.5 years at 1.5 compounded daily. And we can try number 18, 300, 3.5, 7% monthly. So let's try those two. So once again, the formula A equals P parentheses 1 plus R over N to the NT. My goal is to get $1,500 and I need to look for P, so that would be 1 plus. What is the rate? 1.5%, 0.01. That's 1%, and then 5. We're going to compound it daily, 365 days in a year. Once again, N, 365 times 2.5 years, 2.5. Okay. And of course, if I'm going to solve for P, we just need to divide by all of this quantity that is in parentheses, the 1,500. So we divide if you're looking for P. So let's go ahead and first calculate this number, and then we do 1,500 divided by that particular number. So let's go ahead and look for the calculator. Perfect. So we have the following. So parentheses, where am I? 1 plus 0.015 divided by 365 close parentheses raised to parentheses 365 times 2.5 equals that number. So now we know we do 1,500 divided by that number that we just calculated, so 1,500 divided by second answer in my case. So we will need 1444.79 in 2 days. So we can guarantee that in 2.5 years, we'll have our 1,500. Okay, so we need practically 2.5 years to get our next $60, going from 1,444 to 1,500, give or take. So let's see what we have. Let me stop sharing. Never mind. So P, therefore, P equal 1,444.79. The second example, once again, the same thing. A equals P1 plus R over N to the NT. We don't know present, but the future will be 800. That's the goal. P to be determined 1 plus what's my rate? 7%, 0.07 monthly, 12 months in a year, 12 times 3.5 years, so 3.5. Okay, so let's go ahead and do it in the calculator. Let's first calculate all of these. So it's parentheses 1 plus 0.07 divided by 12, close parentheses, raised to parentheses, 12 times 3.5 equals that. Now I do my $800 divided by second answer equals. So now in this case, P equals 626.61. Okay, so let's go ahead and stop sharing, and that will be it. Hopefully you were able to follow. So this is how you solve for present value, having the other 4 variables known. Okay, if you want to try other, no, that will be it. So you have other examples here, and you can practice those. Thank you.